Hey, in this video we're going to be talking about object-oriented programming, and I'm going to get specific and talk about inheritance and polymorphism, and I'm going to follow through making a small project, a farm game, and we'll see what kind of structure you need for object-oriented programs. So I am thinking first, before I write any code, I need to consider what the structure of my game is going to be. I need to think about what kind of objects are involved and what kind of behaviors they're going to have and what kind of interactions they'll have with each other. And all of that kind of determines what code I'm going to write. So I'm thinking in a farm game, the primary thing that you're going to interact with as the player is the farm. So let's make an object, the farm, and on that farm we're going to have a bunch of animals, but we're going to need some sort of structure in order to hold a bunch of animals. Let's say like a grid, so make like a grid in the farm, and we'll make it 4 by 4, so 16 different spots. And in each of these spots could be some sort of object. Maybe it's an animal, or maybe it's a building or something, but it's going to be some abstract idea of something that can be stored in one of these grid spots. And this is the foundation for how we're structuring our object hierarchy, because we need to have the same base class for everything that's stored in this container. So let's say we might have animal, some kind of animal, but we should get more specific than even that. So with an animal, what kind of animals are we going to have? Maybe we'll have cows, maybe we'll have chickens, maybe we'll have pigs, and we'll just stop there because that'll demonstrate enough about it. So each of these cows, chickens, or pigs, they're going to be objects of a class, maybe a cow class, a chicken class, and a pig class. And those classes, they're all going to also be animals, so maybe they should inherit from the animal class, and the animal class can inherit from this grid object class that's going to be stored in this farm grid. And that's mostly for extensibility, making that small abstraction there, so that if I wanted to in the future I could add buildings or other things that are in this grid. For now it's just going to be animals. So that gives me enough to code. Let's think. So I want to make a farm object, so let me add a new item. Let's do farm.h. And so in farm.h we're going to be defining the farm class, farm, and all the stuff it can do and store. It's going to be storing a grid of grid objects, but grid object isn't a type yet. Let's define that. Add grid object.h. I'm just going to make headers for all of these classes, keep them separate and clean, but it's not strictly necessary. Here's a grid object. Okay, and now a farm can store grid object pointers, so references to a bunch of grid objects, and I'm just going to call it grid, and it'll be 4 by 4. So this is a fine place to use a multi-dimensional array. This is a 2-dimensional array. 4 by 4 is going to be 16 elements total. Visual Studio is reminding me that it doesn't know what a grid object is because we have not included the header for it. So it has not seen that definition of the grid object class. Okay, that's set up, and now we can go further with grid objects by making more specific types here is animal. So let's make the animal class, and this is going to need to inherit from the grid object class, so it can be stored as a grid object. So let me include grid object.h, and then inherit public inheritance from grid object. And then I'm going to see a similar pattern of inheritance for all of the derived types of animal. So let me add another header for cow.h. Let me include animal.h. This is going to publicly inherit from the animal class. All right. And then we'll see the other animals are going to be very similar. Right. Here's chicken. All right. And pig. All right, so we're in a place to think now about their behaviors, now that we have this structure down. What kind of behavior is a pig or a cow or a chicken capable of? And this kind of depends on how I am as a player going to interact with them. So one thing I can think of is I might go visit an animal and pet them or something, but maybe they'll say something. So let's see, with a pig, maybe a pig will say oink, and chickens and cows have their own way of speaking as well. And then maybe I can make this leap and say that maybe all animals have some way of speaking. So maybe speaking is a function that belongs in the animal class. I'm going to make this a virtual function, speak, so that it can be overridden by any of the derived classes, so that it can do something different. Now I can provide functionality here, so if I like printed out some message here, something that the animal says, then everything that inherits from animal will have that default behavior. But I can't really imagine what an animal would say. An animal that is not a cow, not a chicken or a pig, just a generic animal, probably doesn't have a way to speak, even though all real animals would. So this is a place where I'm thinking animal actually represents an abstract concept. There is no such thing as an animal. It's more of a classification we use. So in this case, I would not want to provide a default implementation. Instead, I can use this syntax equals 0 to make this not just a virtual function that can be overridden, but a pure virtual function, one that must be overridden. If you do not override this speak function, then you cannot make an object of that class. So now, if I wrote code that said new animal, that would not compile. It knows that animal is an abstract base class. It is a pure abstract concept that cannot be instantiated. So I'm going to have to go into the other classes and implement this function. Here we go. For a cow, I would like to include iostream, throw down this using statement, and I'll copy that over into those other animals as well. Whoa, yeah, there we go. Okay, now in cow, maybe it just says moo. And then in chicken, chickens have their own way of speaking, and pigs have their own way of speaking. Everyone does something a little bit different. And so this is just a simple example of how they could be different. And now if I tell any animal to speak, it will delegate that function call to whatever class it actually belongs to, and call the appropriate function and make the appropriate sound print out to my console. Cool. So in the next video, we will talk about the structure of the game itself and start connecting some of these pieces. See you there.